Okay, so we have seen three ways now, three ways to solve systems. Remember, a system is anything with two or more equations, And remember, when we say solve, to solve a system means to find the x and y that works for both, right? It works for both. We have learned three ways. We first talked about how to graph, right? We graphed it. We graph two lines and we say, okay, where do they cross? Where do they intersect? That's my solution. Then we did substitution. Then we did elimination, right? We're going to focus today on substitution and elimination. Sometimes it's better to do substitution. Sometimes it's better to do elimination. So let me go ahead and just write out the steps again. For substitution, are steps. We want to isolate. That's the key word. Isolate x or y. Okay? Isolate x or y. Go ahead and copy that down. Isolate. Isolate x or y. Step 2, you want to substitute. Substitute to the other equation. Okay? Isolate, substitute to the other equation, and then step 3, solve. Okay, so let's box that up here. Substitution, you want to isolate x or y, substitute into the other equation, and then solve. Okay, so the key thing is if you can isolate really easily, go with substitution. Okay, if you can isolate really easily, go with substitution. Now for elimination, our steps, first step you want to multiply to get or to create opposites. Right? You want to multiply to create opposites or to get opposites. Multiply. Step 2, once you have opposites, you want to add straight down. Add straight down. And then step 3, you want to solve. Okay, so the key words, the key phrases for elimination, you want to multiply to get opposites. So I'm going to circle this word opposites. And then add straight down. Okay, so the key things, guys, if you can isolate really easily, do substitution. Right? Isolate easily, you can do substitution. If you can create opposites really easy with elimination, maybe you have to multiply just a little bit, then go with elimination. Okay, so let's take a look here at just a couple of them. So number 1, looking at these guys, what is easier? Do we have opposites for elimination? 5x and, well, negative 3x. This is not even on the same side of the equal sign. Negative 3y and y. Opposites are not really easy to come by here. Look at substitution. Isolate. Do we have x and y already by themselves completely? No, no. But here, look at this y. He is already fully isolated. So why don't we go ahead and do this one? Right? Y is already isolated. He's by himself. Here are twins. Y is equal to 3x. Y and 3x are twins. So wherever I see y, I could plug in 3x. So we're going to do substitution. Right? We're going to do substitution. Let's write that down. Substitution. Right? The reason is because we can isolate really easily. All right. So I'm going to substitute to the other equation. So instead of writing a y here, instead of y showing up to class, 3x is the twin, so 3x is going to show up instead. So let's rewrite this top equation. 5x minus 3 times equals 8. So instead of 3 times y showing up to class, y's twin, let's put 3x in here. 3x. Okay, so now we've got the y's are gone, so we can solve here. So 5x minus 3 times 3x. 3 times 3 is a 9x equals 8. Let me draw my barrier here. So let's see, I've got like terms. 5x minus 9x. That looks like different signs. Subtract. So 9 minus 5. 9 minus 5 is 4. but take the sign of the bigger number. That's a negative 4x. Okay, so we want to solve, get x by itself. Let's divide by negative 4. Divide by negative 4 here. So this becomes 4 over 4 makes a 1, negative over negative makes a positive, so we get x equals 4 divided by 8. 4 goes into 8 2 times, but there's a negative down here, just one of them, so x is negative 2. All right, now that I have that, I can plug this into either equation, either this one right here or this one right here. Who looks more simple to you? And I hope you said the bottom one, so let's go ahead and rewrite that. So y equals 3x. You can write the x, or you can skip this step and just write y equals 3 times, and we think x is negative 2. So 3 times negative 2, so y equals, well, 3 times 2. 3 times 2 is 6 with a negative in front. So our solution, where do these two guys cross if you were to graph them? X is negative 2, y is negative 6. There it is. All right, so let's take a look at number 3 here. Number 2, again, you want to think about for yourself which one's easier, isolating or getting opposites, right? Substitution or elimination. But let's look at number 3 here. Can we isolate? Is he isolated? No. Isolated? No. Isolated? No. Isolated? No. So we have an option here. You can isolate. Who is the easiest to isolate here? It's the one without the coefficient. It would be this guy right here, right? You can isolate y. You can do substitution. Or you could do elimination, right? Because opposites are pretty easy as well. Here, we don't have good opposites. I mean, you could multiply to get 10 and negative 10 and positive 10, right? Negative 10 and positive 10. But here, excuse me, the opposites are pretty easy. We have negative 2. We just have to make positive 2. So you could do substitution here, but let's do elimination here. Elimination. We're going to multiply to create opposites right here. Negative 2, positive 2, right? Negative 2y, positive 2y. So we're going to rewrite this equation. Let's go ahead and rewrite this. 5x plus y equals negative 9, right? Because we want to multiply to get opposites. So what are our opposites? Negative 2 and positive 2. So we need to multiply to turn this guy into a positive 2. Right now he's a positive 1. So what does he need to become 2? He needs a 2, right? Because 2 times 1 gives me a 2y. And that's exactly what I want to be opposites. So that's going to become 2y. I have to multiply by 2 on both sides. So we're multiplying to get opposites, and then we're going to add straight down. Let me just get more space here. All right, so let's distribute. So don't feel, if you do substitution, you're going to get the same answer. So don't think you have to do elimination here. So we get 10x, 2 times 5 is 10, plus 2 times y is 2y, equals 2 times negative 9. 2 times negative 9. 2 times 9 is 18 with a negative in front. All right, that's this guy right here. I'm going to write the top guy. I think I have space here, so I'm going to write him on top. Negative 2x. You can put him underneath if you don't have space. Minus 2y equals negative 6. So now we're done with step 1. We have multiplied to create opposites. Good job, us. So now we're going to add straight down. So let's see, different sign, subtract 10 minus 2. 10 minus 2 is 8x. And what do we have here? These are our perfect opposites. This is a 0 pair, so this becomes 0. And finally, what do we have here? Negative and a negative. Negative and a negative, same sign, keep and add. 18 plus 6. 18 plus 6 is 24, but we keep the sign, so negative 24. All right, this 0 doesn't really matter, so I'm just going to get rid of him. So 8x equals 24, negative 24, excuse me. So if we divide by 8 on both sides, divide by 8, we get, that becomes a 1, x equals 24 divided by 8. 24 divided by 8 gives me, 8 goes into 24 3 times with a negative in front. All right, so we've got x equals negative 3. We're going to plug him in, either top or bottom. Let's just choose the bottom one for fun. So 5x plus y equals -9. But now we know that x is -3. So 5 times -3 plus y equals -9. 5 times -3, -15 plus y equals -9. Draw my barrier here. Oof. Kind of a diagonal barrier, but we'll have to deal with it. All right, so let's take stock here. What do we have? We want to get y by itself. Who's hanging out with y? -15. How do I get -15 to go to the other side? What's the opposite of -15? +15. So we'll do that on both sides. +15 on both sides. And that's going to give me a 0 pair right there. So y equals, let's see, that looks like different signs. Subtract. How much space is between 9 and 15? 10, 11, 12, 13, 14, 15. That's 6. Take the sign of the bigger number. Positive wins, so y equals 6. So if I was to graph these, where would they cross? What is the point that works for them both? The point is x is -3, comma y is -6. This is our solution. This is the point that works for both. All right, and finally, number 5. So remember, we have a choice, guys. We can do substitution. Substitution, let me back up here. Substitution means we isolate x or y, then substitute into the other equation and solve. Or we can do elimination. Elimination means we're going to multiply to get opposites, add straight down, and solve. So looking all the way down at the bottom, the key word is, can we isolate for substitution, or can we get opposites for elimination? Isolate easily or opposites easily? What do you guys think? Is there any x or y that's completely isolated by themselves? I don't see any. And the problem is, look, they all have numbers in front of them too. So isolating number 5 is going to be pretty tough. Substitution looks tough. You can do it, but it's a little bit more problems. Let's look for elimination. Can I make opposites easily? Do I have opposites? Ooh, look at that. Perfect opposites. -5, +5. -5x, +5x. These are opposites. So because I can make opposites easy, I'm going to go with elimination. Elimination. So step 1, we're going to multiply to create opposites. We don't have to do any work because look, these are already opposites. Step 2, we're going to add straight down. So let's add straight down. That's going to give me a 0. It's going to give me a negative, let's see, 10 minus 9 is a 1, but it's a -1. So let me erase that. Sorry, that's going to be a -1y. -1y. And let's see, this is going to be different sign, subtract. That's a 6. Take the sign of the bigger number, -6. So -1y equals -6. The 0 doesn't really matter, but I can get rid of this -1 by dividing both sides by -1. So this makes a 1 here, so y equals 6 over 1. 6 divided by 1 is 6. A negative divided by a negative. A negative divided by a negative is a positive, so y equals +6. Y equals +6. Let's go ahead and plug it in. Ooh, these both look kind of weird. Who has less negatives? This guy's got 2 of them, this guy's got 1, so why don't we go with this guy right here. Plug him in. So -5x plus 9y equals 4. But I'm going to plug in 6 for y right here. So -5x plus 9 times 6 equals 4. Okay, let me draw my barrier here. So -5x, 9 times 6, 9 times 6. Well, 10 times 6 is 60, so 9 sixes is just 6 less than that. 60 minus 6 is 54. 9 times 6 is 54. Equals 4. Interesting. I've got x here. I want to get x by itself. I want to get rid of this -5. I want to get rid of this 54. Get rid of the 54 first. What is the opposite of 54? How can I move him over? I'm going to subtract 54 on both sides. All right, so 54 minus 54. 54 minus 54 is just 0. So I get negative 5x equals, what is this? This looks like different signs. Subtract negative 54. So think about 54 minus 4. 54 minus 4, that just gives you 50, right? So that's going to be 50. 54 minus 4 is 50. Take the sign of the bigger number. The negative team is much stronger, so we get negative 50. Okay, let's divide by negative 5 to get our x here. Divide by negative 5. So we're going to get, that's 5 over 5 is 1. Negative over negative makes a positive. So x equals negative over negative. Negative over negative makes a positive. 50 divided by 5. How many times does 5 go into 50? 5 times 10 is 50. 5 times 10 is 50. So our solution, which ones work for both? X is going to be 10, write the x first as always, and y is going to be 6. X is 10, y is 6, and there is our answer. X is 10, y is 6. Okay, we're on the back. We're not going to do too much. I want you guys to work pretty soon. But remember, for these guys, you want to look, and you may use either method. Right? You can use substitution or elimination. Substitution or elimination. So the key thing is, if you can isolate really easily, then go with substitution. For example, this one, I don't see anybody that can really easily isolate. But this one, number 9, you might want to go with substitution because look, you can get this x by itself really pretty easily, right? You don't have to do it. You could use elimination, but if you want to isolate x, you could write it like this, and then just get rid of this 2y. I mean, just think about how would you get rid of this 2y? What would you do to both sides to get rid of that 2y? And you could do it that way, okay? But if you cannot isolate easily, the other word you're looking for is opposites, right? We're going to multiply to create opposites. If you can get opposites really easy, you're going to go with elimination. Elimination, right? So if you can isolate really easily, go with substitution. If you can get opposites really easily by multiplying, get elimination. So look at number 7. You see how, if I look carefully, see how these x's are already opposites? See that? These are already opposites. So I would go with elimination because you can just add straight down right here. I would go with elimination for number 7. Think about which one is easier. Do you have opposites? Sorry, can you isolate for number 8? Is there anybody by himself or really easy to get by himself? Or do you have opposites if you go straight down for number 8? So think about that. Number 9, again, I would say you could either isolate x, and I'll just reveal it if you haven't seen it yet. You can just subtract 2y from both sides. You can subtract 2y from both sides. You'll get 0 pair. You'll get x equals, these are not like terms, so you get negative 2y plus 12. Negative 2y plus 12. And look, you've got your twins now. X equals negative 2y plus 12. So you can plug that in right there to the other equation, right here. If you don't like that though, you can go with elimination. You can multiply to create opposites. I'm not going to force you to do one way or the other. You can multiply to get like 10 and negative 10, right? 10 down here, negative 10, or negative 2, positive 2. You would do it that way. All right, so for each one of these, just look and ask yourself, can I isolate? I'm going to go with substitution. Can I create opposites? I'm going to go with elimination. And last but not least, don't forget to graph. I just wanted you to practice this again. And you want to ask yourself, is it in y equals mx plus b form? Y equals mx plus b form. Remember, if we do that, we're going to begin and move. Right? Begin and move. Begin on the y-axis and then move. Okay, so for this first one, if I was to do this in red, our m equals 2. Right, 2, right, that is 2 over 1. And our b for this one, our b is negative 1. So for this first one, you were going to begin at -1 on the y-axis, not the x-axis, and then you're going to move, right? You're going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, or down 2, left 1, down 2, left 1. Okay? Something like that. And then you would do the same for the green guy. Looks like this is also slope-intercept form, so begin and move, and number 12 as well. All right, so keep working.